Good afternoon. My name is Dwayne Brown with the Office of Communications, and welcome to NASA headquarters. For you baseball fans out there, this is NASA's version of a doubleheader. We have two panels. This event, not only will you learn more about NASA's New Horizons mission to Pluto, but the spacecraft's connection with the legendary Voyager 2 spacecraft, where today, New Horizons crosses the orbit of Neptune on the exact 25th anniversary of Voyager's historic encounter with the giant planet in 1989. We'll then take a brief intermission, and around 2 p.m. we'll go to panel 2, where you hear from the New Horizons science team members giving personal accounts of their work during the Voyager-Neptune encounter and their new assignments on the Pluto mission. We'll be taking questions here in the auditorium at NASA headquarters, our phone lines, and on social media. There is quite a buzz on social media about what's coming up in 2015 in this incredible mission. Send your questions into #AskNASA. We want to welcome all of the schools. This is the first day that they're coming in across the nation. Many of them watching. Stay in class, but if you have questions, we'll try to get them answered. And if we can't do that in today's two panels, we'll get to them as soon as possible. Send those questions in to #AskNASA. And of course, all of this information and any updates on the New Horizons mission will be on www.nasa.gov/New Horizons. So let's get started, but let me introduce you to our participants for panel 1. First off, Jim Green, Director, NASA's Planetary Division, Science Mission Directorate, NASA headquarters in Washington. Ed Stone, Voyager Project Scientist from the California Institute of Technology, Pasadena, California. And Alan Stern, New Horizons Principal Investigator, Southwest Research Institute, Boulder, Colorado. And with that, I'll hand it over to Jim.
Thank you very much, Dwayne. May I have my first graphic, please? In this particular illustration, we see the sun on the left and the very distant star, Alpha Centauri. The distance between our sun and Alpha Centauri is approximately 4 light years away. In other words, it takes 4 years from light from the sun to reach Alpha Centauri. Now what we've done is we've stretched that inner part of what we call the sun's influence, gravitational influence, as you can see, out to the edge of its gravitational influence at the Oort cloud. This is a cloud of comets. It's approximately 1 light year away, very far. So our sun's gravitational influence is enormous. But the other boundaries that are important here are the heliopause. This is the region where the solar wind and the solar magnetic field interface and interact with the winds from other stars. You know, our solar system is truly immense. And today we have an opportunity to talk about those outer heliospheric explorers. And if I have the next slide, please. These are those explorers. In planetary science, we've taken the approach of flyby, orbit, land, rove, and return samples. And for the outer heliosphere, we're currently flybys. And our top explorers exploring the outer parts of our heliosphere, Pioneer 10 and 11, Voyager 1 and Voyager 2. And now New Horizons is making a major milestone today. That exact day, 25 years ago, that Voyager 2 flew by Neptune and made fabulous observations of a brand new world. Now these missions are uniquely American. No other nation can accomplish the exploration of our outer heliosphere as this nation does. And the only way we can do it is through some unique capabilities. The most important part of these missions from a power perspective is the radioisotope generator, an RTG, that each of them carries with it. Now the sun, its light is so low at that location in the outer parts of our heliosphere that we need to take the power with us. These are important radioisotopes that as they decay, plutonium-238, it generates an enormous amount of heat and also power. We use that for these missions and only these missions to be able to accomplish their beautiful, spectacular flybys and really probing and understanding the outer reaches of our solar system. I want to take now the minute to tell you about the fabulous encounter Voyager 2 had of Neptune. That occurred 25 years ago today in spectacular fashion. And next year, New Horizons will fly by Pluto and give us a new and unique view of that body that we've so wanted to know about. So let me turn it over to Ed Stone to take you back 25 years and tell you about the exciting encounter of Voyager 2 with Neptune. Ed?
Yeah, thank you, Jim. The Voyager's 12-year journey to the giant outer planets, Jupiter, Saturn, Uranus, and Neptune, really revealed the remarkable diversity of bodies in the solar system. Before Voyager, the only known active volcanoes, the only known active geysers were here on Earth. And then at Jupiter, we had our first bookend where we found its moon Io, the size of our moon, but with 10 times the volcanic activity of Earth and active geysers, volcanoes erupting on its surface. That set the stage then for Saturn and then Uranus, and first, if I could have the first slide, finally Neptune. Where we had the last bookend of this story that Voyager revealed. Neptune is the large blue sphere you see on this approach image, and down below, near the bottom edge, is a small light-colored dot. That's Triton. It's in an inclined orbit, and we had to fly over the north pole of Neptune very steeply down to where Triton was in its 6-day orbit around Neptune. So if I could have the video, please, which was done by Jim Blinn back before the Neptune encounter, showing the exact flyby that Voyager was about to take and ideas about what we might see at Neptune and then at Uranus, then at Triton. So here's the Voyager spacecraft headed toward its polar passage, our closest flyby of any planet within 3,000 miles of the top of the atmosphere. A very close flyby which deflected the spacecraft steeply downward. And you can see there were belts and zones, perhaps large areas of turbulence, which were imagined in this model of what Neptune might look like, because we really didn't know. Over the North Pole, as I say, the closest planetary flyby we had, then steeply down to its encounter with the moon Triton. And again, you'll see an artist's conception of what we might expect. Triton was captured by Neptune and probably had a very geologic activity early in its history. But we had no idea really what it was going to look like. There were many surprises ahead for us. And in the next slide, you will see one of the first big surprises. Next slide, please. And that is a great dark spot. So here is Neptune, which is 30 times as far from the sun as the Earth. 1/900th of the sunlight energy is here on Earth, yet here's a storm system Earth-sized. So this planet also had the highest speed winds of any that we had seen in the solar system, over 1,000 miles per hour. So once again, we were surprised to find such an active atmosphere so far from the sun. And of course, in the 5 years after this image was taken, Hubble looked and the great dark spot had disappeared. So unlike the great red spot at Jupiter, it was not durable, and a smaller or another dark spot up north appeared. On to Triton. After we flew by Neptune, Triton, as I say, was, I'm sorry, I want the next slide, please. Well, this is a flyover which Paul Schenck actually put together from Voyager images as we flew over there. This is Triton, and you can see that the polar cap in the southern region is actually frozen nitrogen. It's so cold, 38 degrees Kelvin above absolute zero, minus 409 Fahrenheit. So cold, the nitrogen is frozen. Yet even at such cold temperatures, you notice in that bright polar cap, there are dark bands, deposits. Those are deposits of geysers erupting in the ice, even at 38 degrees above absolute zero. They launch dark material about 5 miles up, and then it trails by the wind about 100 miles downwind of the eruption. And there were 4 such plumes active at the time Voyager flew by. So even at the most remote edges, we have an active, alive surface on this cold little moon. Next slide shows, in fact, the unusual nature. Next slide, yeah, the unusual nature, this so-called cantaloupe terrain, which was produced presumably by internal heating, perhaps early on, but perhaps even more recently, and large, long, linear-like fault systems, which are part of this very dynamic moon. Next slide shows a region where obviously a large area has been filled with icy lava, because the surfaces here are ice, not rock. And so the feeling is that this is a very, very young surface. In fact, it might be even changing today. In fact, Alan Stern actually suggested maybe 15 years ago that there was still liquid inside of this moon. So that certainly suggests that this may still be alive, even or more, at least most recently. So the last video, next video, is one which Paul Schenck put together, reanalyzing the Voyager data. It flies you over this very unusual terrain. You can see the long ridged fault system. You can see the very textured terrain, which is called the cantaloupe terrain, which is presumably the result of internal heating effects. There are very few impact craters that may turn out this surface is less than 100 million years old, maybe only a few million years old. Really quite a surprise. And you can see up in the upper left one of those large basins that is filled with an ice flow, other regions where the ice has flooded the surface and erased some of the topography which was there from an earlier epoch. So that's what we found at Triton. In fact, only recently has this data been analyzed to show these wonderful images and suggest that this is still a lively world. And it's about the same size as the moon, as the planet Pluto, and about the same composition. So it's certainly possible that the surface on Pluto will also show some remarkable changes associated with a very active geologic life. Time will tell. And with that, I will turn it over to Alan.
Well, thank you, Ed. Thank you, Jim. It sounds like science fiction, but it's not. Today, our spacecraft crossed the orbit of Neptune outbound for Pluto. We've waited a long time for something like this. A lot of people have worked very hard on it, and it's really only possible for 2 reasons. One is that we stand on the shoulders of giants, giants like Ed Stone and his Voyager science team that pioneered how to do the exploration of the deep outer solar system. And giants like the Voyager project as well. That project team really is our mentors, if you will. But in addition to the giants whose shoulders we benefit from, the experience they gave us on New Horizons, over 2,000 Americans worked for almost 15 years to conceive, design, build, test, and now fly this spacecraft all the way across our solar system. Some of the members of that team, which I call the New Horizons core of discovery, are here today as representatives, and I'd like those folks to stand up and take a bow. If you're on New Horizons, please stand up, and if you're not, would you please join me? It's an amazing accomplishment. Thank you very much. Now I want to tell you a little bit about our mission. We're going to start with a video that begins at our launch in January of 2006. Let's start the video.
2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to visit the planet Pluto and then beyond. Plus 15 seconds. Everything continues to look good as the Atlas V vehicle climbs away from Florida's east coast. The 5 solid rocket strap-on boosters are burning just fine, sending the New Horizons spacecraft on its way to the very edge of our solar system.
Well, after we got off that launch vehicle over the Atlantic Ocean, we flew halfway around the Earth to the injection point to take us to Jupiter for a gravity assist, ignited the Centaur stage and then a Star 48 motor that put us on a hyperbolic trajectory out of the solar system. Onward to Jupiter. This is the fastest spacecraft ever launched. Made the crossing to Jupiter in just 13 months, arriving in February of 2007, where it precisely hit the aim point to fly on to Pluto 8 years later. We crossed the space between Jupiter and Saturn in record time, crossing Saturn's orbit 2008, on to the orbit of Uranus, which we crossed in March of 2011. And for the last 3 years, we've been cruising at this very high rate of speed across the next billion miles. Today, we crossed the orbit of Neptune, as I said, outbound for Pluto, and to make a little history. Well, there's more to tell you about this. And if I can have the next graphic. This is an overhead view as if you're looking down on the solar system today. The giant planets and Pluto are depicted at their actual positions today. The yellow line is our route of flight from down where the Earth is, orbiting close to the Sun. And we are just at the orbit of Neptune, which you can see we're crossing today. On the next graphic, you can see for comparison Voyager's route of flight, which was very close. Those corners in that trajectory are where it made giant planet flybys. It did not, of course, go to Pluto because Pluto was not there in 1989. Pluto was pretty far around to the left in this diagram. But if you look to the right, you'll see Neptune, which has now moved quite a ways from where it was when Voyager encountered it 25 years ago today. In fact, as we cross Neptune's orbit, we are 2.5 billion miles away, 4 billion kilometers. And since we're doing that crossing, we thought it would be fun to use the spacecraft during its checkout this summer to make an image of Neptune and Triton, its large planet-sized moon. And we'd like to show that to you. This image was made on board New Horizons, again from a distance of 4 billion kilometers. It's in the next graphic. That's Neptune with Triton at the 10 o'clock position just off the edge. They're so far away, they're only points of light. We don't see the kinds of detail to make the discoveries that Voyager could. That's the power of going close. That's the power of having a space program that can fly to these planets and reconnoiter them. In the next slide, you see a little bit more. We point out where Triton and Neptune individually are. This summer, we also began our optical navigation campaign using onboard cameras to home in on the Pluto system. And in the next graphic, we're going to show you a series of images made in July, just last month, of Pluto and its large planet-sized moon, Charon, orbiting each 6 days as Charon goes around Pluto. You'll notice Pluto wobbling back and forth by the tug of Charon's gravity. This is the first such approach image of many that we'll be showing you as we fly up to and through the system next July. In the next graphic, we have a state-of-the-art artist's conception of what Pluto may look like. I have to tell you, it's very far away. It's very hard to study because of its distance, its faintness, even with all of our modern technology. Everything we know about the Pluto system today would probably fit on one piece of paper. What do we know? Well, we know that Pluto is surprisingly made primarily of rock. It is a rocky planet, 70% rock by mass. It has a fascinating escaping atmosphere made up of nitrogen, the same thing that you're breathing in this room for the most part, and other gases, mostly in trace constituents. Pluto has winds. It has polar caps. It has a fascinating surface that we know is changing with time, and an atmosphere that's undergoing global change. And it has a system of at least 5 satellites. This is just mouth-watering. It is a scientific wonderland that we look forward to exploring, and it's one of the reasons that the National Academy of Sciences, through the decadal survey process, ranked this mission at the very top for funding years ago that resulted in this project. But let me tell you the other reason, what I think is the real reason that this mission got such high priority. So on the next chart, I want to introduce you to the Kuiper Belt. This is something new. It's something that we didn't even really know about until the 1990s, and yet it's the largest architectural structure in our planetary system. Beyond the orbits of the giant planets is a vast region, billions of miles across, populated by trillions of comets and who knows how many small planets like Pluto. It is a revolution in planetary science so profound that we realized what we used to call the outer solar system, where the giant planets reside, is actually the middle zone of the solar system. It is the Kuiper Belt that is the third zone, the true outer solar system. And within it, a new class of planet, the dwarfs. We didn't know they were there. We thought Pluto was a misfit, and now we see it in context. There are many of them. In fact, more dwarf planets than all the giants and terrestrials combined. You might ask yourself, who's the misfit now? Let's go to the next graphic. Look at some of these guys, and they're depicted here with their satellites in their true colors. They have very different surface appearances, very different compositions in many cases, different numbers of satellites. Who knew the solar system was like this when we all went to school? It is truly a paradigm shift in planetary science. And what New Horizons is doing is flying to the biggest and the brightest, the first discovered, and from what we know, the richest, most complex of these dwarf planets in the Kuiper Belt, to the Pluto system. That kind of paradigm shift, if I can have the next graphic, is what brought this mission to the fore for the National Academy of Sciences 2003 Decadal Survey in Planetary Science to rank this #1 on the runway for New START funding. And as a result, we were able to build and launch New Horizons in the succeeding years. And now I'm going to tell you a little bit about what we're going to do when we get there. If I can have the next graphic. We have a marvelous little spacecraft. The model here on the table is a model of the same thing that's being depicted on your screens. The actual spacecraft is about as wide as this table. Not shaped like the table, but about as wide. It's very highly miniaturized compared to Voyager. It has, through the advantage of being 2000s technology, it has much greater capability for first reconnaissance in terms of the instrumentation on board than we could fly in the 1970s. It's carrying the most sophisticated suite of reconnaissance instruments ever brought to bear on a first reconnaissance flyby in the history of humankind. Cameras and spectrometers, in situ plasma and dust instruments. We're going to map the Pluto system. We're going to map all of the satellites. We're going to map Pluto itself. You're going to see it in color. We're going to obtain over 1 million spectra telling us about the composition of the surface. We're going to see the composition of the atmosphere. We're going to measure its escape rate. We're going to determine its structure with altitude, look for hazes, look for new satellites, look for rings, and do many more things. We're going to make thermal maps. It's going to be a bonanza for science in so many ways, and we're going to take you along in all of this journey. If I can have the next view graph. This, it's nice to make the cover of the Rolling Stone. This is an actual image of Jupiter and its volcanic planet-sized satellite Io, taken by New Horizons in 2007. It's actually a montage. Io was taken separately from Jupiter. But it shows you the power of the kinds of things you will see when we get to Pluto. And I have to tell you, our instrument suite was built to operate in the dim twilight, very far from the sun where Pluto is. In fact, at 500 million miles from the sun, Jupiter and its satellites were almost too bright for our instrumentation to be able to look at. So we're going to do even better than this. Now, what will we find? As I said, we don't know very much about Pluto. Let me show you the best image we have of it. It's made by the baddest gun we have. Next image. This is made by the Hubble Space Telescope. That's Pluto, seen from Earth orbit. And you can't tell very much about it. That's part of the best part. We don't know a thing now, and a year from now, we're going to write the textbooks. If I can show you the next graphic, this is a familiar object. This is the Earth at the same resolution that we currently have for imagery of Pluto. What could you tell about the Earth at this resolution? Almost nothing, and you'd probably get most of it wrong. We may have most of it wrong about Pluto. We'll find out. Let's look at the true Earth. How could you tell what this planet is really like at the limiting resolution that we have from here? That's why we're sending New Horizons. And we have tremendous capability on this spacecraft. I spoke about some of it, but let me say a little bit more. If we were to fly over the Earth at the same altitude that we will fly over Pluto and look down with our long focal length camera, not on Pluto, but on the Earth, we'd have something like this image. This is New York City in the inset. And it's too bad it's not blown up a little further, but If you look and you're familiar with New York City, you can see Brooklyn, you can see Manhattan, you can see the Hudson along the one side of Manhattan and the East River on the other. You can see the Long Green Strip, which is Central Park. And if you look closely, you can count the ponds in Central Park. You can actually see wharfs on the Hudson. You can see the main thoroughfares coming down through Manhattan and the shapes of the largest buildings like the American Museum of Natural History. Now, I don't think we're going to see any of that on Pluto, but that's the kind of detail that we're going to have in the highest resolution 70 meter per pixel images of the Pluto system. On both Pluto and its satellite Charon, we will see this kind of detail, and I have to tell you, in the history of first reconnaissance flybys, we have never had the capability to do imaging at this resolution before. So fasten your seatbelts. 2015 is going to be amazing. Next view graph. Put it in your calendar. We'll be there on Bastille Day, Tuesday, July the 14th. But the encounter actually begins in January. And all the way from January into May, we'll be navigating on the Pluto system, making environmental measurements of the heliospheric environment and dust and plasmas where Pluto orbits. And then, beginning in May, we exceed Hubble resolution, and it will get better week by week until we swoop, diving through the satellite system halfway between Pluto and its innermost moon, Charon, about the diameter of Texas, all the way through the system and back out the far side where we will look back to study the atmosphere and solar and stellar occultations and to make other kinds of studies before we exit, hopefully for a journey into the Kuiper Belt, if later approved. It's going to be very exciting. And it's the first time in a generation since our heroes on Voyager took us to a new planet for first time raw reconnaissance, where we go from a single piece of paper in our knowledge to writing the textbook. I'm going to close with a little video that is about New Horizons. And so why don't we run that right now?
Five, 4, 3, 2, 1. We have ignition and liftoff of NASA's New Horizons spacecraft on a decade-long voyage to Pluto and then beyond.
Can't wait to take you along. Dwayne?
Whew. Okay, so let me first say that you gave a shout out to the incredible team, and ladies and gentlemen, I'm going to pick up where Jim Green was talking about the power source. We are fortunate to have as guests, and they're really not guests, they're partners of an incredible organization that without them, as Jim said, we wouldn't be able to do these incredible deep space missions with the power source. We have representatives from the Department of Energy, DOE here, and I would like to give them a round of applause for what they do. Made in the USA. And if they'll be available here during the program or after for folks, particularly on Twitter and social media, if you have questions about the incredible design of that power source. I would also like to remind folks that are watching this show, if you go to the website, there's an actual countdown clock that, as Alan said, July 14th is a countdown clock, so you can stay abreast. And with the school systems opening up all across the nation, particularly in this area, Alan, I have a feeling there are going to be a lot of school projects starting next year about Pluto. So what we're going to do here is open it up for questions. I believe I'm going to go to the, we have one question here. Then we're going to, if you wait for the mic, identify yourself. Then we're going to go to the phone lines, and then we're going to go to social Media. So, sir, if you can identify yourself, please.
Sure. Jeff Faust, Space Review. Question for Alan. I wonder if you could give us a progress report on the status of finding a potential Kuiper Belt object that New Horizons could visit after the Pluto flyby?
Yeah, thank you for that question. As many of you know, there's a possibility of an extended mission for New Horizons. In fact, that decadal survey actually called the mission that we're flying the Kuiper Belt Pluto mission, indicating the importance of flying on beyond Pluto to explore small Kuiper Belt objects. But to explore them, we first have to find them. They're very faint. They're very far away. These are objects that are much smaller than Pluto and probably much more primitive in terms of their chemistry and their appearance. These are objects the size of counties, for example, not the size of planets. They're very faint, and we've been using the largest ground-based telescopes in the world for about 4 years. And although we've been discovering Kuiper Belt objects, none in that region of space, none have been within our fuel reach. So we proposed to the Hubble Space Telescope, which has even better capability for this kind of search, and we're awarded time in June. And the basic search is now complete. Hubble has done a spectacularly good job and has yielded literally hundreds of images of that part of the sky, from which we found some candidates. We don't know if any of them, though, are within our fuel reach, and we won't still for some months, because we have to track them as they move in their orbits to accurately determine where they orbit and how that compares to where Pluto orbits, so we can determine the delta V, the amount of velocity change we have to make, and compare that to our fuel supply capability. We hope to know before the year is out, and we will keep you posted as soon as we've made a determination whether there are reachable objects. We certainly hope so.
Okay, let's go to social media. So I'm going to turn it over to my colleague, Felicia Chow. What's going on in the Twitter world?
Well, Dwayne, we're getting some really great questions from social media. One of the questions that keep popping up is, what are some major things that NASA is hoping to learn through this mission? Garrett from Twitter asks, what data from the flyby are you most excited for?
Well, I think like most people, I'm most excited just to see the Pluto system revealed. You know, along with others on the team, some of us started on this quest to explore Pluto and the Kuiper Belt almost 25 years ago, about the time that Voyager was making its flyby of the Neptune system. So I think of the Pluto system as a Christmas present that's been sitting under the tree for 25 Christmases, and we're going to unwrap it, that present, next July. So I'm looking forward to the imagery. As the principal investigator of the ultraviolet spectrograph, I'm also looking forward to all those squiggly lines that'll tell us about the composition of Pluto's atmosphere and the pressure and temperature structure in the atmosphere, what it's made of as a function of altitude. But I think if you talk to different people on the team, they tell you different things. We have so many talented scientists on this team and such a richness of data sets that New Horizons will return, that almost everywhere you look, there are going to be presents under that tree. And we look forward to showing them to you beginning next summer.
Another question.
Folks on social media are also wondering about tech specs of the New Horizons spacecraft. Ryan from Twitter asks if you can elaborate a little bit more about the types of new technology that are equipped on this vehicle compared to the Voyager 2 in '89.
Well, let me tell you, one of the breakthroughs of New Horizons is that it's a breakthrough in terms of being a low-cost outer planet deep space mission. In fact, New Horizons costs about 2 dimes on the dollar compared to Voyager, which is a breakthrough in itself. And part of making that breakthrough was not to try to develop too many new technologies, because those would drive cost. But the two that I'd like to tell you about that are very important are, first, the technology to hibernate the spacecraft, which we've done most of the way across the solar system. Most of the time, the spacecraft is more or less sleeping, which saves greatly in terms of the wear and tear on the electronics boxes. When we reach Pluto, after 9.5 years of flight, the typical avionics or electronics box on the spacecraft will be less than 3 years old, because it's been sleeping most of the time. And the technology to do that and do it at low risk, do it safely, let the spacecraft take care of itself without being watched by large teams of flight controllers, is something we've really contributed to the stable of technologies that Jim Green and the planetary program can use in the future. The other thing is the miniaturization in the 7-instrument payload. You know, all 7 instruments that return all those different kinds of data on New Horizons together weigh less than just the camera on the Cassini Saturn orbiter. And combined, when they're all 7 running with their flight microprocessors, draw less than 1/2 of the power of a 60-watt light bulb. It's just amazing, the technology in the instrument payload on New Horizons. And that's where perhaps our biggest advance is.
We'll take one more, and then we'll go to the phones, Felicia.
Okay. What are some major challenges of sending a spacecraft so far out?
You want to speak to that? You did that. You did that.
Go ahead. You've got the experience in that one.
Well, there are a lot of challenges. One is, of course, if you have to worry about the temperatures. Very cold out there at the very edges of the planetary system. The communication is very difficult at great distances, so you need as large an antenna as you can afford to launch and as high a power transmitter as you can afford to power. You need to be able to protect the spacecraft if you fly anywhere near a planet, especially Jupiter, against the radiation environment which is out there.
Now, I'd like to add to that a little bit. You know, the radioisotope power capability has improved greatly over the time period. Department of Energy has done a fabulous job continuing to improve our systems and giving us more and more power. You know, on Pioneer 10 and 11, they actually literally died on us. Pioneer 10, I believe, was at 50 astronomical units, and Pioneer 11 maybe at 60 astronomical units. But by the time we went to that next generation, which was the Voyagers 1 and 2, they're going strong. And they're well beyond the heliopause, Voyager 1 is, at more than 120 astronomical units. So even the power systems have developed enormously.
And if I may, I'd like to chip in one more thing. You've heard from both Ed and from Jim about the technologies that are required to do this, but it also requires people. And we're very fortunate on New Horizons to have a very dedicated team of scientists and engineers and mission control experts. And almost everyone on our team has been with us since before launch. It's very important because it's very easy over the course of a long mission to forget something, to make a mistake, which is very human. But we've had the privilege of having a very stable team of very talented and dedicated people who've worked all these years since 2006 to deliver this spacecraft for prime time, if you will, in 2015. And I'm very proud of that team.
Okay, let's go to the phone lines, and then we'll come back for social media and then wrap up. Let's see. For the phone line, I believe we have Alan Boyle from NBC News. Alan, are you there?
Yes, thank you for taking this question. I think this is for Alan, and it relates to plans for public engagement during the mission. Could you talk a little bit about what activities you might be planning as you get closer to the flyby, and how the images might become available? Is there going to be a daily dose of imagery from the mission? Thank you.
Sure, Alan. Well, we plan to engage people a lot of different ways, ranging from the web and social media to booklets to kits so that you can have your own party around the Pluto encounter. We call them Pluto-paloozas. And anybody in a school, in a business, in a home, in a club, an astronomy club, a classroom can put a Pluto-palooza together next summer at your own convenience. We're going to be posting all of the high resolution, all the images from our high resolution imager, Lori, to the web as JPEGs, and everybody knows how to use a JPEG. Just click, and you'll be able to see those same day that they appear on the ground, and we receive them as they come in. We're also looking forward to many other forms of engagement. Some of them we'll keep to ourselves and roll them out as we go, but as I said, we want to bring you along through this, and you're going to see more and more, and not just from the New Horizons team and the NASA team, but also from the Planetary Society, from the Space Foundation, and other groups that are getting involved, because this is the first opportunity in a generation to really explore a new planetary system for the first time. And I looked it up. In terms of the demographics in the United States, approximately half of the people were not born at the time of Voyager, at its last stop at Neptune, or are too young to remember. So for them, this is a whole new experience. When I was growing up, you know, we had the privilege of seeing the first orbiter at Mars and the first landers. and then the first missions to Jupiter and Saturn and Uranus and Neptune. And they were enthralling, and they were mind-blowing in terms of the richness of nature. But there hasn't been anything like this yet in a long time. 2015 is your year, and we're going to bring every tool to bear that we can think of to help you come along with us beginning in January.
Our next caller is Mike Wall from Space.com. Mike?
Okay, hi. Thanks again for actually doing this, guys. This one's also for Alan. I was just wondering if you could give us an update about the search for new moons in the Pluto system. Like, is that still ongoing? And if it's not, when do you expect to sort of pick it up? And sort of how does that complicate your path just kind of through the Pluto system? Thank you.
Okay, thank you, Mike. So as many of you know, when we were selected to do this mission, it was just lonely Pluto and Charon. And then in 2005, we were lucky to get some Hubble time to look for more satellites. And in the space of an afternoon, the Hubble discovered two, called Nix and Hydra. Later, in 2011 and 2012, the Hubble discovered more moons, which are now named Styx and Kerberos. And there could well be still more. We've looked in the Hubble data sets as deeply as we can with independent expert teams, and we don't see any more moons yet. But on approach, our imagers will well surpass what Hubble can do from 3 billion miles away. And we'll be looking very hard for those satellites, not only for their scientific value, but to make sure that we don't run into harm's way. Not that we expect to hit a satellite. You can calculate the odds of that, and it's extremely low. There could literally be 100 new satellites, and the odds of hitting one would be very small. But there can be hazards from debris that comes off the satellites, and we've made, like any good space mission team, we've made backup plans. We estimate that there's less than a 1% chance we'll have to use those, but those plans are now in place, so we're ready for that part of the encounter. And as we make the approach, beginning about in April, we'll be looking very hard for small satellites that may be orbiting close to Pluto or far from Pluto. And if discoveries are made, we'll be announcing the news of that satellite by satellite on the way in. And it's part of the adventure of unwrapping that Christmas present to find out whether we will find none or one or many. Stay tuned.
Okay, we're going to take one more question from social media, and don't change that dial because we have the second part of our doubleheader coming up around 2 o'clock, where you will hear some pretty inspiring stories from the team members from Voyager Neptune and what they're doing on the Pluto mission. Don't change that. Felicia?
From Twitter, can you elaborate a little bit more about New Horizons' power source? Larry from Twitter asks, how does the heat from the RTG create power?
Go
ahead.
Yeah. So this device, the RTG as it's called, is filled with plutonium, which, by the way, was named after the planet Pluto. It's nice to be taking a little plutonium that way over to Pluto. And it generates about 5 kilowatts of heat. So inside that thermos bottle, if you will, that black hair curler looking affair, it's very, very hot. But these radiator fins and the outside skin of the RTG are exposed to the cold vacuum of space. So they're very cold. And there's a strong temperature difference between the inside of the skin and the outside of the skin. And using thermocouples, we can actually use that temperature difference or temperature gradient to drive a little current. And from the 5 kilowatts that's being generated as heat, we can develop a little over 200 watts of DC electricity to run the spacecraft systems and the instruments. It's a completely passive device. It just works by sitting there like a heater would. Once it's on, it's on. This has been running our spacecraft since the week before launch when it was fueled in Florida and can continue to run the spacecraft for decades after Pluto. It's an amazing technology developed in the 1960s and refined by the Department of Energy and by NASA over the decades, and it's what we rely on. I call the RTG the really terrific generator because it makes these missions possible.
Okay, so what we're going to do here, we're going to close out so we can transition into our second panel that will start approximately around 2 p.m. Please join me for another round of applause for this incredible mission and team. Questions answered, and I'm pretty sure there are lots that will still come in. Keep sending them in at hashtag #AskNASA. We'll get those answered as quickly as possible. Along with my colleagues at the Applied Physics Laboratory, we will be helping, and all the social media scientists and others, and including questions about the RTG. We have our DOE representatives here to answer any specific questions about their incredible power source. Again, on the website, www.nasa.gov/New Horizons. Ladies and gentlemen, 2015, it's about Pluto, it's about New Horizons. Thanks for joining us. Stay tuned for 2 p.m. to hear some real-life stories. Thanks for joining us.